All right, we are doing homework for 6.3, and we are starting with number 5. So in number 5, we're trying to find the slope of the line just based on the graph. Okay, and we know that it is change in the y, change in the x. We can also write that as rise over run. And so we're looking at what was the change up and down, which is the y value, and the change side to side, which is the x value. And you can see they've already tracked those numbers for you. So the increase, the rise going up was 1. And the increase to the right was 1. So the run is 1. So 1 over 1 just equals 1. And the slope on number 5 is 1. Now, in number 6, as soon as I look at this graph, I know this is a negative slope because as this line moves from left to right, the way you read, it's going down. Okay, so sometimes students struggle. They'll look at this one and say, well, I could go down 1 over 1 this way. How do I know which way to go? Everything's from left to right, just like you would read a sentence left to right. So this line's going down. I automatically know that this is going to be a negative answer. It went from here to here, left to right. It went down. Okay, rise is the up and down, the y value. Went down 3. And then after it went down 3, it went over 1. So it's negative 3 over 1, which we can just simplify down to negative 3. So the slope there is negative 3. Okay, number 7. 3 pieces to these. First piece is going to be to graph the line. So just a quick sketch. We've got the point 2, 2 and a slope of 4. So before I start making all my tick marks, I'm going to think about, I'm going to be at 2, 2, and I'm going to have to go up 4 because of that slope. So I need to make sure that I've got enough tick marks to accommodate for all of that. All right, so 2, 2 is over 2, up 2. Here's my point 2, 2. And if there's a slope of 4, that's like 4 over 1. And so this is my y. I'm going up 4, and I'm going over 1, always from left to right. So from this point, I'm going up 4, 1, 2, 3, 4, and then over 1. And on this question, part B is always to find another point. So the easiest thing to do is just identify that next point that you had right there. So for part B, I'm going to go ahead and identify that point. So the x value, I only went over 1, so I was at 2. I'm now at 3. I was at 2. I went up 4, so that is 6. This is 3, 6. Just a quick sketch like this. And part C now, I want you to check your second point that it's actually on the line using the slope formula. So if this truly is on this line, then when I compare this point to the point that was given, 2, 2, and I use the slope formula, so I'm going to go ahead and put 2, 2 right under this so I can compare those two. The slope between these two better be 4. If it's not, then I made a mistake. 3, 6 is not on that line. So it's y2 minus y1, x2 minus x1. We've talked about that it doesn't matter which one you call which. I'm just going to go from top to bottom here. So I'm going to do 6 minus 2 for my y's, and I'm going to do 3 minus 2 for my x's. So since I went from here to here, I need to go from here to here. You could go the other direction, of course, but you just need to be consistent. Whatever you do on the top, you got to go the same direction on the bottom. So I'm going to get 4 up top, and I'm going to get 1 on the bottom, which equals a slope of 4, which checks out. That's exactly what I wanted. Okay, so number 8, same idea. And you can see a lot of people complain about the graphs. It doesn't have to be anything fancy. Okay, just put enough lines on there that you can fit what you need. So number 8, we're starting at 4, negative 2. So 1, 2, 3, 4, 1, 2. And we have a slope of negative 2, 3. So that's down 2 over 3, always from left to right. So from here, I'm going down 2 over 3 going to look like that, just for a quick sketch. That's fine. Now for part B, our initial point here again was 4, -2. And so if I went down 2 on my y, I went from -2 down 2. That's -4. And if I was at 4 on my x and I went over 3, I'm now at 7. So you can pull this from the graph. You could count over. You could say this is -4, 7 to find this point. Or you can just look at the numbers directly and just minus the 2 from the y to get -4, add the 3 to the x. So remember, this is the y and this is the x, and get that number. So I'm going to go ahead and compare it for part C. I'm going to subtract my y's on top. I'm going to do 7 minus -2. So again, I went this direction. I got to be consistent and go this direction on the bottom. So it's -4 minus 4. So I'm going to go ahead and go plus plus here, and that's going to be +9. What did I do wrong here? Oh, something's incorrect here. Let's take a look. If you just look at this point, see, I could already see the slope wasn't going to come out. So that's the whole point on letter C here, is to double check your answer. These answers are going to have to produce a 2/3 slope. This was about to give me an 8. I was going to have a 9/8, which is not equal to 2/3. So something's wrong. As I look at my x value, I was at 4, and I went over 3. I reversed these on accident. Okay, this is 7, -4. So hopefully you caught that as we were going through it and you were confused. So I was at 4, and I went over 3. So the 7 is the x value, and I was at -2, and I went down 2, so -4 is my y value. So I had those backwards there. So let's try this again. So the whole point of letter C is to double check yourself, run a check. Our check just caught that we had the wrong answer, so that's perfect. Exactly why we do letter C here. So change in y now. I'm going to go from -4, and I'm going to minus -2. And then going this direction, I'm going to do 7 minus 4. So this goes plus plus. -4 plus 2 is -2. 7 minus 4 is 3. That checks out. That's exactly what I need. And by using the slope formula to check my answer, I caught that I made a silly mistake and reversed my x and y. And hopefully from that you can see the purpose of why we do letter C. Just a quick check of our answer. Number 9. So find another point on the line with the given slope and containing the given point. So very similar to what we just did, but basically you can do it with the graph if you're comfortable with the way we just did it, or we can make an adjustment using this. So we know slope is change in y over change in x, and they're telling us the slope here is -3, and that means if it's just a whole number, then that's a 1 on the bottom. So the change in the y would be a -3. So here's my y, changed by -3, so 4 minus 3 becomes a 1. And my change in the x is a +1, so I'm going from -3 and I've got a +1, so that's going to be -2. Now there's all different answers. If you put this on the graph, maybe you went the opposite direction. Okay, but I think this is the easiest way to adjust it. Just a quick check of what that would look like on a graph. This was not part of the question that you had to do. We have -3, 4. So we're up here. And we're going down 3 and over 1, and that's where this -2, 1 came from. Okay, we went down 3, so the 4 became a 1, and then we went to the right 1, so -3 became -2. So if it helps you just to quick visualize it so you feel comfortable with your answer, you can see that. So number 10, same idea. We've got 4, 1, and we've got a slope of 0. Now we can have a 0 in the numerator. We cannot have a numerator in the denominator. That would be an undefined slope. this one may definitely help to visualize it. So we're starting at 4, 1. So 4, 1 is going to be right here. And we know that a slope of 0 is a flat line. So it's going to be a line that looks like this. And so you can pick any other point that's on this line. You could even pick the point where it hits the y-axis, or one over here. As I go from left to right, the x value is changing. It goes down into the negatives. It goes farther in the positives. But when I go from here to here, the up and down has not changed because the slope is 0. So my y value, or the 1, is going to be there. Okay, so for number 10, I know that this has to be a 1. And then you can literally pick any number you want here, because from 0 to positive infinity, from 0 to negative infinity, every number will be included on this line. So you can pick any number you want in here. So I'm just going to pick 52 just to demonstrate that any number you put in there is fine. But 1 must be your y value, because no matter where I go on this line, if the slope is 0, it's not going up, it's not going down. The y value will be consistent. Oops. Next question we had was number 12. So number 12, it says, graph the line through negative 1, 4 with an undefined slope. So undefined slopes go straight up and down. So just a real quick sketch here. Negative 1, 4 is going to be up here. So negative 1, 1, 2, 3, 4. And if it's undefined, it is going to go straight up and down and stay at negative 1 the entire time. So contrasting with the last one we just did, an undefined slope, the y value can be anything, up to positive infinity, down to negative infinity, but my x value will always be the same, and so my x value is always going to be negative 1 on this question. All right, from 12 we are going to 19. So we are graphing again here on 19. And you can see it's not the prettiest graph, but it works. That's all you need to do. All right, so on the graph paper, we're going to plot the point 0, 0. That's right here in the middle, called the origin. We're going to draw lines going through 0, 0 that have the following slopes. So line A has a slope of 3. So line A, the slope is 3 over 1. So that's up 3 over 1, up 3 over 1. If I was going to continue it this way, you'd have to go down 3 to the left 1. Okay, and so I'm going to draw that line and label that A. Line B, exact opposite, negative 3, 1. So again, starting at 0, 0, but now I'm going down 3 over 1. Now it's always to the right. I can't emphasize that enough. For your over, it's from left to right. So I'm going down 3 over 1 to the right, down 3 over 1 to the right. And so this line looks like this. Because a lot of students will go down 3 left 1, and now you're creating a positive slope. So after you've drawn your line, always go back and check. A was supposed to be a positive 3 over 1, so as it goes from left to right, it's going up. B is supposed to be a negative 3, 1, supposed to be going down. Okay, and we've got that, so we're good. Label this B. C is going to have a 1/3 slope, so you can see they're using consistent numbers and just placing them in different places in our slope fraction. And so this is positive, so it's up 1, and then it's always to the right 3. So from here I'm going up 1 over 3, up 1 over 3. So it's a positive slope, it's going up, but at a much slower rate than the one that was a positive 3. 3 is bigger than 1/3, so that means the slope is much faster or steeper. So here's C. And letter D now is going to be the negative 1/3 slope. So again, we're going down because it's negative, but always going to the right. So down 1 over 3, down 1 over 3. So this is going to have a negative slope. but just at a much slower rate. We'll call this letter D. All right, now we got to answer all these questions. So letter A. Which lines are slanted upward as you read from left to right? So from left to right, letter A goes up, and letter C also goes up. Question B. Which lines are slanted downward? So letter B goes down, and letter D goes down. So C, can you relate the slant of the line to the slope of the line? Of course we can. So A and C were slanted up. B and D were slanted down. So A and C both had positive slopes. So positive going up. B and D both had negative slopes, and so it's slanted down. Letter D. Which lines are the steepest? So we have A, which is very steep going up. We have B, which is very steep going down, and that's based on the number. Okay, 3 is going to create a steeper line than a 1/3 because it's bigger. And so for letter E now, give the value of a slope that is steeper than any slope on the 4 lines. So to create a slope that's steeper, we need a bigger number than 3. So any number bigger than 3. So 4 would be fine. -4 would be fine as well. Okay, so we're actually looking at the absolute value, because if you say a bigger number than -3, you might say 1. Well, 1 is not actually going to be steeper than this, so it has to be -4 or -5 or -6 to create that steep negative slope. And so the absolute value of 4 or -4 or 100 or -100, okay, those will create a steeper slope than 3, and any fraction that's less than 1, like 1/3 or -1/3, which is absolute value, it's less than 1. Okay, those are going to be slopes that are not as steep. Okay, 21. So we're given an equation, we want to find the slope. When we have a slope that's in y equals mx plus b form, we know the slope is found right here. So if we're given an equation that's not in that form, if we can manipulate it a little bit and get it into that form, it's very easy to see the slope. So that's what we're going to do here. Y equals form, y equals mx plus b, the y is by itself. So here's the y. If I can get all the rest to the other side, I now have it in y equals mx plus b form, and whatever the coefficient is of x, that's going to be my slope. So the mistake people make is they look at this and they go, hey, whatever's attached to x is a slope. Slope must be 12. But you'll see when we actually get this in the proper form, 12 is no longer the coefficient of x. So first thing we're going to do is we're going to minus 12x from both sides, because that will get it out of here. And again, our final goal is to get the y completely by ourselves. So we have -8y. On the other side, you have 4 minus 12x. You cannot put those together. Okay, one has an x, one does not. They're not like terms. They need to stay separate. Now, this form, we're traditionally going to have that x up front. So if you're comfortable, put the -12x up front. +4 would go next. If you're not comfortable with that, you can write 4 minus 12x. There's nothing wrong with that. So I'm going to go ahead, though, and put the x up front. It was minus, so it's negative. The 4 is positive, so it's plus. If you feel like you're going to make a mistake there, then go ahead and write 4 minus 12x. These say the same thing. Okay, we need to understand that. All right, and now our last step here is going to be divide by -8 to get rid of it here. This entire side needs to get divided by -8. So when I do that, first of all, a negative and a negative is going to be a positive. I'm going to write 12/8 for now. We can simplify that. Now a positive and a negative is going to make a negative, so it's going to say minus 4/8. That'll simplify right away because I know that's 1/2, but if you left it there, it's fine. So this now is my slope. I do need to simplify it. So I could divide these by 4, and it's going to be a 3/2x. And so my slope is 3/2, which you could divide and turn into a decimal, and that's the way the book gave their answer. It's 1.5. So the key on these questions is you have to isolate y. We've spent so much time working on equations. We know how to get y by itself. Whatever the coefficient is of x, that's your slope, and you should simplify it as much as you can. All right, and we are on to 23. Got 23 through 26 here, and we're all set. So 23 and 24, we're going to be looking at the graph and the chart. So 23, between which 2 years was the greatest increase in unemployment rate for men and for women? So part A, we'll just look at men. You can look at the chart, and I think it's pretty obvious. You can see based on the graph where that big jump is going to be. So men are on the green line, so you want to look, where is it the steepest? Where does it go up the fastest? And you can clearly see at the end it actually goes down. Okay, so we want to know the greatest increase in unemployment. This line looks a little flat. It looks like it goes up between 2001 and 2002. So we'll double check that with the numbers. Then it definitely looks like it flattens out. So if I had to do it just based on the graph, I'd say between 2001 and 2002. If we double check that, 4.8 to 5.9 from 2001 to 2002, it went up over 1 because 4.8 to 5.8 would be 1. It went all the way up to 5.9. The only other part I have in question is possibly between 2000 and 2001. So if I check that, it's slightly under 1% because 3.9, if I went up 1, would be at 4.9. It's at 4.8. So that went up 0.9, and then from here it went up 1.1. So sure enough, the greatest increase was between 2001 and 2002. You can see that in the chart, just running the numbers. You can also see it on the graph. That's going to be the steepest point. So part B now. Where was the greatest increase for women? If you look at theirs, it looks flat. Looks like it goes up. Looks like it gets flat. So once again, it looks like it's between 2001 and 2002. Go ahead and double check that. 4.7 to 5.6. It almost went up a whole percentage point. That would get up to 5.7. So since it's 5.6, that went up 0.9. If you double check anywhere else, here it only went up 0.1. Here it went down. The only other place that it could possibly be is 2000 to 2001. And that went up 0.6 if you're looking at it. So 0.9 is the biggest increase. So between 2001 and 2002. Same answer for both men and women. Okay, 24. What was the rate of change between 2001 and 2003? So rate of change is going to be the change per something. So it would be the change in the percentage per year. So we're going from 2001 to 2003. So anything in between 2001 and 2003, those values are not going to be part of our equation. We're just looking at the change from the beginning to the end. Okay, this is like slope. Rate of change is slope. So the change in the unemployment rate here, you're going to do 6.3 and you're going to subtract 4.8 and you're going to try and see how much did the unemployment rate change. And it was by 1.5. Now, if it went down, you would call that negative. Okay, so we went y2 minus y1. If you want to try and memorize which order it goes in, that's fine, but I think it's better just to be just straightforward with it and just look, it went up, that's positive. If the unemployment rate went down, that'd be negative. Okay, so make sense of it instead of memorizing, it always goes this direction or whatever. Just make sense of it. It went up, it's positive. And how many years is that over? So that's from 2003 to 2001. So clearly that's 2 years. And so what we're going to do is we want to figure out what was the change per year. So we want the change per year. So you're putting the years on the bottom. How much it changed divided by how many years. You divide those two numbers, which is 1.5 divided by 2. And that will tell you how much is changing every single year. So when I do that, it's 0.75. And that's the percent, because this is unemployment rate, which is the percent of people per year. And if I take 0.75 twice, I've got 1.5. It was over 2 years. So if it went up 0.75 each year, after 2 years, it's gone up 1.5. Now, clearly, it didn't go up consistently by 0.75 every year, but the average, the rate of change was 0.75. So this was all part A because that was the men. So let's do the same thing now for women. Same dates, 2001 to 2003. So we went from 5.7 to 4.7. So clearly that was a 1% change. And again, that's over 2 years. From 2001 to 2003, that's 2 years. So we're going to take how much it changed over 2 years and convert that into how much is it changing each year. So over 2 years, it went up 1, which means it went up 0.5 each year, 0.5 first, 0.5 the second year. Now we're at 1. So where does that come from? That's 1 divided by 2. So that's 0.5 or 0.5% a year. All right, 25. Find b if we have y equals mx plus b. So this is our slope-intercept formula. And they're going to give you a bunch of values, just not giving you b. Everything else you can plug in for. So we're starting off with y equals mx plus b, and we're plugging in for everything that they've given us. So y, they told you, is negative 10. M, they said, is 3/4. M is being multiplied by x. X is 5, so we're multiplying times 5. And we're trying to find b. That's what we don't have. Okay, so we need to manipulate this formula. So b is isolated by itself, and it says b equals. So first thing I need to do is go ahead and multiply. Now remember, this is always over 1. So if I just multiply by hand, if I didn't plug it in the calculator, which perfectly you can, it's perfectly fine to do that. But I'm going to get 15 over 4. And if you prefer, you can go ahead and you can do 15 divided by 4 and turn that to a decimal, since it is a nice decimal. So I'm going to get 3.75 from this. Everything else I'm going to just drop down. So negative 10 equals 3.75 plus b. And so if I want to solve this, I'm just going to minus 3.75 from here. And so when I go ahead and bring everything down, b is now isolated. And when I subtract this, it's negative 13.75. Could have left it a fraction as 15 over 4 and let the calculator handle the fractions. That would have been perfectly fine. Your answer could have been given as a fraction. Okay, and last question, number 26. We have a quadrilateral that's a 4-sided shape, quad, 4 sides. The perimeter is 70, so if I added up all the sides, it equals 70. We want to find n. So I'm going to add up all of these sides, and they're going to equal 70. So I just have to write that out as one big, long equation. The order that you do it doesn't matter. So I'm going to start with 4n minus 3. If I add n plus 4, and I add 2n minus 4, and I add 2n plus 1. Just be careful, make sure you get them all there. That has to equal 70. Now you may like to just put everything together at first, and in fact that's the way I would normally do it, but just showing you what this all represents, I'm going to write it all out. So I got to combine all of these. So 4n and 2n is 6n, plus another 2n is 8n, plus 1 is 9n. So 4 plus 1 is 5, 6, 7, 8, 9. And then I also need to put negative 3, positive 4, negative 4. So right away, I can just go ahead and cancel those two. That's just going to give me 0 when I combine those. And I have a positive 1. So I have a negative 3 and a positive 1. That's going to be a negative 2. And you could have done that on here. Negative 4, negative 3 is negative 7. Over here I have 5, positive 5. So negative 7, positive 5 comes out to negative 2. So simplifying everything comes out to 9n minus 2, which is going to equal 70. So I'm just adding 2 to both sides and dividing by 9. And n equals 8.